you ever wondered what remains when you take absolutely everything away? Imagine for a moment that you could reach out into the vast expanse of the cosmos and begin to gently empty it. You sweep away the swirling galaxies, those magnificent ancient islands of hundreds of billions of stars that drift quietly through the dark. You carefully remove the planets, the isolated moons, the ancient asteroids, and the wandering comets that trace long, silent paths across the void. You clear out the sprawling nebulae, those glowing clouds of primordial gas and dust where new stellar lives are patiently born. You even reach into the unfathomably cold spaces between the stars and pull out the solitary atoms of hydrogen that float in the freezing dark. Finally, you sweep away the light itself, removing every ancient photon traveling from the very edge of the observable universe, erasing the residual glow of the Big Bang and leaving nothing but absolute darkness. What are you left with? Common sense tells us that once you remove every single piece of matter and every single trace of energy, you are left with nothing. Pure, absolute emptiness. A quiet, featureless, infinite void. But the universe, in its boundless mystery and breathtaking complexity, holds a secret that defies our deepest intuitions. When you strip away everything that can possibly be removed, the space that remains is not empty at all. It is boiling with energy, teeming with invisible structure, and humming with a quiet, continuous symphony of creation and destruction. This is not a philosophical abstraction or a poetic metaphor. This is the honest truth about the fundamental nature of our reality, discovered through decades of rigorous scientific exploration. You are about to embark on a quiet journey into the most profound and mind-bending realization of modern physics. We are going to explore the hidden architecture of existence, the invisible foundation upon which all of reality is built. We are going to dive into the infinite depths of the quantum field. To truly understand this mystery, we must first gently let go of the way we usually perceive the world around us. We are creatures evolved to navigate a realm of solid objects. We feel the heavy weight of a stone in our hand, the firm resistance of the ground beneath our feet, the gentle caress of the wind against our skin. Our brains are beautifully, evolutionarily hardwired to understand the universe as a vast, empty stage where solid particles act out the physical drama of existence. For centuries, even our most brilliant scientists shared this comforting, intuitive view. Classical physics, the magnificent intellectual edifice built by Isaac Newton and his successors, described a universe made of distinct, localized particles moving through the passive, empty, silent container of space. But as our scientific instruments grew more precise, as we peered deeper into the microscopic heart of matter, this intuitive picture began to gently fracture. When physicists in the early 20th century began to unlock the secrets of the atom, they found that the solid world was an illusion. They discovered that an atom is almost entirely empty space, a ghostly architecture with a tiny, dense nucleus orbited by fleeting electrons. But the true revolution, the paradigm shift that shattered our understanding of nothingness forever, came with the development of quantum field theory. This theory, which remains the most successful and rigorously tested mathematical framework in the entire history of human knowledge, tells us that the fundamental ingredients of the universe are not particles at all. Instead, the foundation of reality consists of continuous, invisible, fluid-like entities that fill every inch of space from the center of your beating heart to the most distant, silent edge of the observable cosmos. These are the quantum fields. Imagine an infinitely large, perfectly calm ocean that extends forever in every conceivable direction. When the ocean is perfectly still, it is invisible. You cannot see its surface. You cannot feel its presence. It is a quiet, gentle state of absolute potential, a serene silence stretching into infinity. But if you add energy to this ocean, if a storm rolls in or a gentle gust of wind sweeps across its surface, waves begin to form. The water rises and falls, creating localized ripples of energy that travel across the vast expanse. In the beautiful, rigorous language of quantum physics, that invisible ocean is the quantum field, and the ripples on its surface are exactly what we call particles. Every single electron in the entire universe is not an isolated, solid little microscopic sphere. Instead, it is a tiny, localized vibration, a fleeting excitation in the electron field, a single, unified field that stretches unbroken across the entire universe. When you look at your own hand, you are not looking at a collection of isolated, independent particles. You are looking at a complex, beautifully orchestrated symphony of vibrations in multiple, overlapping quantum fields. The electron field ripples to create the electrons in your atoms. The up quark field and the down quark field ripple to create the protons and neutrons in your atomic nuclei. You are, quite literally, a localized storm of energy in an ancient, infinite ocean of fields. This realization brings with it a profound sense of awe and a deep, comforting, intellectual humility. We spend our daily lives feeling separate from the world around us, contained safely within the boundaries of our skin. But the scientific reality is far more beautiful, far more strange, and infinitely more connected. The exact same electron field that vibrates to create the atoms in your body right now is the exact same continuous field that stretches out across the freezing, quiet void of intergalactic space. It is the exact same field that forms the electrons in the swirling, superheated accretion disk of a supermassive black hole a billion light years away. There is absolutely no separation. You are an emergent property of the universe, a temporary, highly complex knot in the fundamental fabric of the cosmos. The invisible fields that make up your body have been here since the primordial moments following the Big Bang, nearly 14 billion years ago. They have witnessed the birth of the very first stars, the violent, spectacular collisions of ancient galaxies, and the slow, patient, quiet cooling of the expanding universe. And they are here right now, quietly humming in the silence of this present moment, sustaining your very existence. But the mystery deepens even further when we return to our initial question about absolute emptiness. What happens when a quantum field is in its lowest possible energy state? What happens when there are absolutely no ripples, no waves, no particles at all? Even in this state of perfect theoretical stillness, the field is not truly empty. Due to a fundamental, unbreakable principle of nature known as the Heisenberg uncertainty principle, a quantum field can never be completely, perfectly quiet. It is fundamentally mathematically impossible for a field to have exactly zero energy. Instead, it possesses a baseline level of activity that physicists call zero-point energy. Even in the deepest, darkest, coldest vacuum of empty space, far from any star or galaxy, the quantum fields are constantly, endlessly bubbling and frothing with activity. This profound phenomenon is known as quantum vacuum fluctuations. If you could somehow zoom in on a region of perfectly empty space, magnifying it to a scale billions of times smaller than a single proton, you would not see a smooth, quiet, peaceful void. You would see a chaotic, seething, endlessly active landscape of energy. Ghostly entities known as virtual particles are constantly popping into existence out of the pure vacuum, borrowing a tiny, microscopic amount of energy from the field itself, and then instantly annihilating each other and disappearing back into the void from which they came. Electron and positron pairs, quark and antiquark pairs, ephemeral photons of light. They emerge from nothingness and vanish back into nothingness in a tiny fraction of a single nanosecond. This continuous, violent, microscopic dance of creation and destruction is happening everywhere, all the time, without end. It is happening right now in the vast empty space between the distant galaxies, and it is happening right now in the empty space between the atoms of your own body. The universe is profoundly, inescapably alive with invisible energy. This is not merely a theoretical concept born from mathematical equations. Scientists have proven the existence of these virtual particles through meticulous, brilliant experiments. They have measured the tiny, subtle physical forces that these fleeting ghosts of matter exert on real, solid objects, a beautifully strange phenomenon known as the Casimir effect. The vacuum of space is not a passive, silent stage. It is an active, dynamic, essential participant in the unfolding cosmic drama. When you step outside on a clear night, look up at the sky, and see the profound ancient darkness between the glowing stars, you are not looking at an empty void. You are looking at a vast, infinite ocean of quantum potential, humming with ancient energy, waiting for the exact right conditions to burst forth into matter and light. The sheer scale of this realization is staggering, a true testament to the wonder of the natural world. We live our lives naturally focused on the macro world, on the immediate things we can touch, see, and interact with. But the true machinery of existence operates on a level that is forever hidden from our direct, unaided perception. The universe is a breathtaking masterpiece of hidden architecture, a delicate, unimaginably precise balance of forces and fields that interact with mathematical perfection. It is a system of such exquisite complexity that our human minds often struggle to truly comprehend its scope. Yet, the fact that we can comprehend it at all is perhaps the absolute greatest wonder of the cosmos. Human beings, small, fragile, temporary creatures, living on a tiny rock in an unremarkable, quiet corner of a vast galaxy, have somehow managed to peer behind the heavy curtain of reality. We have used our mathematics, our brilliant scientific instruments, and our boundless driving curiosity to uncover the invisible ocean that connects us all. We have patiently learned to read the quiet, hidden language of the quantum fields. As we continue on this contemplative journey together, we will slowly dive even deeper into this invisible world. We will explore how these different fields interact, how they magically grant mass to the universe, and how they intimately shape the fundamental nature of reality itself. We will discover together that the universe is far stranger, far more mysterious, and far more beautiful than human beings could have ever possibly imagined. So, take a moment to simply breathe. Let go of the rigid, solid world you thought you knew. Allow yourself to gently feel the invisible, eternal connections that bind you to the farthest, darkest reaches of the cosmos. You are not just a passive, isolated observer in this universe. You are a living, breathing, conscious expression of its most profound mysteries. The quantum field is not just around you. It is you. And as we venture further into the quiet unknown, we will find that the deeper we look into the fabric of reality, the more we discover about ourselves, our place in the cosmos, and the infinite, quiet wonder of existence. Have you ever held a smooth, heavy river stone in the palm of your hand and quietly wondered where its profound weight actually comes from? We feel the solid, comforting pull of the earth gently drawing us downward, grounding our bodies to the floor, holding the vast oceans firmly within their deep basins. It feels so incredibly fundamental that we almost never pause to deeply question it. But if, as we have discovered on this gentle journey, the universe is fundamentally constructed not of solid billiard balls, but of ephemeral ripples in invisible quantum fields, a magnificent paradox quietly emerges. How exactly does a mere vibration, a fleeting wave of energy in a boundless silent ocean, suddenly acquire the stubborn reality of mass? How does the ethereal architecture of the cosmos crystallize into the heavy, grounded world we experience every single day? To unravel this beautiful mystery, we must first look at something in the universe that possesses absolutely no mass at all. Consider a single ancient photon of light traveling from a distant galaxy, sailing silently across the freezing darkness of the cosmos. A photon is a delicate ripple in the electromagnetic field, moving through the universe completely unimpeded. Because it has exactly zero mass, it is destined by the unbreakable laws of physics to travel forever at the absolute maximum speed allowed, roughly 186,000 miles per second. It never slows down. It never grows tired. From the moment it is born in the fiery heart of a star to the exact moment it gently strikes the retina of your eye, a photon simply glides through the quiet void, eternal, weightless, experiencing no resistance and no anchor. But the invisible particles that make up your physical body, the electrons and quarks that assemble perfectly into your complex atoms, do not behave like weightless light. They are stubbornly heavy. They possess mass. They can be slowed down, and they can rest in quiet stillness. For a very long time, the mathematically rigorous equations of quantum physics could not explain why this was happening. The beautiful mathematics flawlessly described the existence of the fields, but when physicists solved the equations, the math predicted that absolutely all particles should be completely weightless, flying eternally through the cosmos at the speed of light. If that were the actual truth of reality, atoms could never form. Molecules could never bind together to create liquid water or solid stone. Stars could never ignite in the ancient dark, and you and I would simply not exist. The breathtaking resolution to this profound cosmic puzzle is one of the most elegant discoveries in the entire history of science. Brilliant physicists realize that there must be another field, a completely different kind of invisible ocean, pervading every single inch of the vast universe. This is now known as the Higgs field. Unlike the other quantum fields, which gently bubble and fluctuate around a baseline energy of exactly zero, the Higgs field is profoundly different. Even in the deepest, emptiest, most freezing vacuum of intergalactic space, the Higgs field is permanently switched on. It hums with a constant, silent, non-zero energy value everywhere, all the time, without exception. It is an ever-present, invisible background, permeating the entirety of existence, from the center of a black hole to the quiet space, right in front of your eyes. Imagine walking along a quiet, dry beach. You can move freely, your arms swinging through the empty air without effort. Now, imagine wading gently into the ocean until the water reaches your chest. Suddenly, every single movement requires conscious effort. The dense water gently but firmly resists you. You feel heavy, physically anchored. This is precisely how the Higgs field operates on a microscopic level. As the ripples in the electron and quark fields try to move through the universe, they must constantly wade through the thick cosmic syrup of the Higgs field. It is this continuous, eternal interaction, this gentle, microscopic cosmic friction that manifests in our macro world as mass. The more strongly a particle interacts with this silent field, the heavier it becomes. An electron interacts weakly, making it incredibly light. Light does not interact at all, slipping through unimpeded. This was a beautiful theoretical idea, a mathematical masterpiece meticulously sketched on blackboards for decades. But science naturally demands rigorous empirical truth. To prove that this universe-spanning field actually existed, humanity built the largest, most complex machine ever constructed. Deep underground, safely buried beneath the quiet borders of Switzerland and France, the European Organization for Nuclear Research built the Large Hadron Collider. This magnificent circular tunnel, stretching 17 miles in circumference, was designed to accelerate tiny protons to an unimaginable 99.9999% the speed of light. Inside this quiet, freezing underground ring, scientists smashed these particles together with terrifying force, creating fleeting fireballs reaching temperatures 100,000 times hotter than the center of our sun. They were trying to strike the invisible Higgs field hard enough to create a ripple, a single localized wave that our delicate instruments could finally measure. And finally, in the year 2012, after decades of patient searching by thousands of dedicated minds across the globe, they found it. They discovered the Higgs boson, the tangible physical ripple in this invisible cosmic ocean. It was a monumental triumph of human curiosity, a breathtaking moment where our small, fragile species reached out and gently touched the fundamental architecture of the cosmos. By finding the boson, they physically proved the existence of the infinite field that gives our universe its weight. When you quietly absorb this profound truth, the way you experience your own body begins to change. The comforting weight of a heavy blanket resting over you on a cold night, the firm resistance of the solid chair beneath you, the grounding embrace of someone you deeply love. All of these profoundly human experiences are the direct result of invisible quantum fields interacting with each other in the silent dark. Your physical substance, your very gravity, is a continuous, intimate relationship with the fundamental fabric of the universe. You are not simply placed into an empty container. You are deeply entangled with its life-giving essence. Your weight is a beautiful, eternal conversation between your atoms and the infinite cosmos. Look once again at the seemingly empty space around you. It is not a void. It is a dense, energetic, humming medium. The Higgs field is there right now, passing silently through your room, through your atmosphere, through your skin and bones. It is the invisible, ancient anchor preventing the atoms of your body from instantly dissolving and flying apart at the speed of light. It is a quiet, eternal embrace holding the physical universe beautifully together. Without this invisible presence, there would be no intricate structure, no complex chemistry, no fragile biology, no life. There would be no magnificent planets drifting in the quiet dark, no swirling galaxies spinning in the void, no conscious minds to wonder at the beauty of it all. The realization that emptiness is a complete illusion, that space is a thick, vibrant medium, brings a profound sense of intellectual peace and cosmic humility. We are gently sustained by the universe in ways our eyes can never see, held together by ancient, invisible oceans of energy existing since the primordial dawn of time. Yet, even as we begin to grasp the majestic reality of the Higgs field, another, even deeper mystery quietly beckons to us from the shadows. For the tiny subatomic particles that make up our bodies account for only an incredibly small fraction of the total mass in the entire cosmos. There is something else out there in the vast, quiet, dark, something invisible, something incredibly heavy that we cannot yet touch or understand. As we continue our gentle journey together, we will have to venture far beyond the familiar fields of our own bodies. We will explore the silent, invisible ghost that shapes the grandest structures of the cosmos, quietly binding entire galaxies together in an eternal cosmic dance. Have you ever stood outside on a crisp, deeply quiet night, far away from the glowing lights of any human city, and simply tilted your head upward to gaze at the sprawling canopy of the cosmos? When you look up at that vast, glittering expanse, you are instinctively drawn to the light. Your eyes trace the ancient glowing constellations. You watch the steady, silent burning of distant suns, and perhaps, if the night is exceptionally clear, you might even catch the faint, milky smear of our own galaxy stretching across the darkness. It is a profoundly beautiful sight, one that has inspired wonder and deep existential curiosity in human beings since the very dawn of our species. We look at all that brilliant, radiant matter, and we feel a comforting sense of understanding. We think to ourselves that we are seeing the universe. We believe that the glowing stars, the swirling nebulae, and the planets catching the light of their suns are the main actors on the cosmic stage. But the universe is a master of illusion, and it harbors a mystery far more profound than the brilliant light it so generously displays. The breathtaking, humbling truth discovered by modern astronomy is that everything you can see, every single glowing star, every towering cloud of cosmic dust, every planet, every moon, and every single atom of ordinary matter in the entire observable universe represents only a tiny, almost insignificant fraction of what is actually out there. You are not looking at the universe when you look at the stars. You are looking at the delicate foam on the surface of an unfathomably deep, completely invisible ocean. To understand this gentle, quiet revolution in our understanding of reality, we must travel back to the 1970s, to the patient, meticulous observations of a brilliant astronomer named Vera Rubin. She was not looking at the dense, glowing center of our galaxy, but rather at the quiet outer edges of neighboring spiral galaxies, watching how the lonely stars out there moved through the silent dark. According to the rigorous, well-established laws of physics set down by Isaac Newton and Albert Einstein, the stars at the very far edges of a spinning galaxy should move much more slowly than the stars near the dense, heavy center. Imagine a quiet playground merry-go-round. If you cling to the very edge while it spins rapidly, you feel a powerful force trying to throw you off. The only thing keeping the outer stars of a galaxy from flying away into the freezing, empty void is the gravitational pull of all the visible matter contained within the galaxy itself. But when Vera Rubin carefully measured the velocities of these distant, lonely stars, she found something that completely shattered our understanding of the cosmos. The stars at the very edges were not slowing down at all. They were tearing through space at absolutely terrifying, incomprehensible speeds, moving so fast that the gravity of all the visible stars, all the glowing gas, and all the massive black holes in the entire galaxy combined was not nearly enough to hold them in place. By all the known laws of physics, these magnificent spiral galaxies should have completely torn themselves apart billions of years ago, scattering their stars into the infinite void like glowing dust blown away by a violent wind. Yet there they were, quietly, stably spinning in the ancient dark. The only logical, mathematically sound conclusion was as elegant as it was deeply unsettling. There had to be an enormous, invisible halo of mass surrounding these galaxies, a vast, unseen sphere of profound weight, gripping the rapidly spinning stars and holding the entire beautiful structure together. Scientists called this unseen ghost dark matter. It is a profoundly inadequate name for something so majestic and fundamental, because this matter is not dark like a shadow or a thick black cloud. It is perfectly, completely transparent. It does not interact with the electromagnetic quantum field we explored earlier. It does not emit light. It does not reflect light. And it does not absorb light. It passes through ordinary matter as if we were completely made of nothing at all. If you were to somehow hold a handful of dark matter, you would not see it, you would not feel it, and it would slip right through your skin and bones, falling silently towards the center of the earth without ever touching a single atom of your physical body. Yet, despite its ghostly, untouchable nature, it possesses mass, and therefore it exerts the firm, unmistakable pull of gravity. NASA and the European Space Agency, utilizing the most advanced telescopes ever conceived by the human mind, have meticulously mapped the profound influence of this invisible ghost. The data they have collected reveals a truth that forces us to completely reevaluate our place in the cosmic order. Dark matter does not just exist. It absolutely dominates the universe. When you tally up all the mass in the cosmos, the ordinary matter, the stuff that makes up you, the earth, the glowing sun, and every single visible star in the night sky, accounts for roughly 15%. The remaining 85% of the matter in the universe is completely, perfectly invisible. This is a staggering, mind-bending realization that requires a deep, quiet moment of contemplative silence to truly absorb. We have spent thousands of years studying the physical world, unlocking the intricate secrets of chemistry, biology, and physics, only to discover that the very building blocks of our reality are the exception, not the rule. We are the anomaly. We are a rare, luminous minority, floating in a vast, silent ocean of unseen mass. But how do we know it is truly there if we cannot see it? How do we study an invisible ghost? The answer lies in the majestic phenomenon of gravitational lensing, beautifully captured by the Hubble Space Telescope, and more recently, the magnificent James Webb Space Telescope. When astronomers look at distant galaxy clusters, massive gatherings of thousands of galaxies bound together by gravity, they see something extraordinary. The light from even more distant galaxies sitting far behind the cluster is stretched, magnified, and beautifully warped into glowing arcs and perfect rings. The massive gravity of the cluster is physically bending the very fabric of space and time, acting like an enormous cosmic magnifying glass. But when scientists calculate the mass required to bend the light so drastically, the visible galaxies fall woefully short. The only way the math works, the only way the magnificent images make any physical sense, is if the space between the visible galaxies is absolutely packed with millions of light years of invisible, heavy, dark matter. It is the unseen scaffolding of the universe. If you could somehow put on a pair of magical glasses that allowed you to see dark matter, the universe would transform before your very eyes. The empty, silent spaces between the stars would suddenly burst into view as dense, heavy clouds of invisible particles. You would see that our Milky Way galaxy is not just a flat, spinning disk of stars, but a tiny, glowing seed embedded deep within the center of a colossal, spherical halo of unseen mass, stretching hundreds of thousands of light years out into the deep dark. You would see the cosmic web, the largest structure in the entire universe. It is a breathtaking, infinitely complex network of dark matter filaments stretching across billions of light-years of space. These invisible threads form a majestic cosmic nervous system, and ordinary matter, the gas, the dust, the stars, and the galaxies, is simply pulled by gravity to flow along these hidden rivers of dark matter. Galaxies do not form randomly in the universe. They bloom like beautiful, glowing flowers precisely where the heavy, invisible threads of the dark matter web cross and intersect. Without this silent, unseen architecture, the universe would be a completely different, barren place. The delicate gravity of ordinary matter alone would never have been strong enough to pull the primordial gas together after the Big Bang. The first stars would never have ignited. The galaxies would never have formed. The heavy elements necessary for life would never have been forged in the hearts of dying suns. We owe our very existence, our quiet moments of reflection, our beating hearts, and our capacity for wonder to an invisible ocean of particles that we cannot see, touch, or fully understand. The great astronomer Carl Sagan once beautifully observed that science is not only compatible with spirituality, but it is a profound source of spirituality. When we recognize our place in a universe that is mostly invisible, a universe where the solid reality we experience is just a tiny, fragile raft floating on an unfathomably deep ocean of unknown fields and unseen particles, we cannot help but feel a profound, gentle humility. We are not the center of the cosmos. We are not even made of the main ingredient of the cosmos. We are a beautiful, temporary, luminous byproduct of a universe that is far vaster, far older, and far more mysterious than our ancestors could have ever possibly dreamed. This realization does not diminish our importance. It elevates our existence into something truly miraculous. We are the rare, conscious part of the universe that has somehow evolved the ability to look out into the silent dark and recognize the invisible hand that gently holds it all together. The quantum fields we explored earlier, the electron field, the quark fields, the Higgs field, all interact beautifully to create the light and the matter we know. But the dark matter field, whatever it may ultimately be, remains aloof. It shares the same space with us, passing quietly through our rooms, our planet, and our bodies every single second of every single day. Yet it remains perfectly silent, refusing to interact, refusing to reveal its inner nature. It is a constant, gentle reminder that the journey of scientific discovery is an infinite road. There will always be another mystery waiting quietly in the dark, another layer of reality waiting to be gently uncovered by our boundless human curiosity. As we continue to drift together through this meditative exploration of the cosmos, we must prepare to face a mystery that is even more profound and perplexing than the invisible matter holding the galaxies together. Because while dark matter gently pulls the universe together, providing the heavy anchor for the stars and the planets, there is something else out there in the deepest, most infinite reaches of the void. There is an energy, an ancient, unrelenting force that is doing the exact opposite. It is a force that is quietly, inexorably, tearing the very fabric of the cosmos apart, expanding the infinite distances between the galaxies, and slowly driving the universe toward a future of absolute, freezing silence. To understand the ultimate fate of everything we know and love, we must prepare to dive into the most terrifying and beautiful enigma ever discovered by human science. We must confront the dark energy that fills the vast, stretching emptiness of the quantum void. Have you ever gently tossed a smooth stone straight up into the air and watched how it behaves? As it rises, it inevitably slows down, pulled patiently and relentlessly back toward the ground by the invisible gravity of our massive planet. For most of human history, astronomers and physicists assumed the entire cosmos behaved in exactly the same intuitive way. We knew that the universe was expanding, a magnificent process that began roughly 13,800,000,000 years ago, but logic whispered a comforting assumption. Just like that rising stone, the immense gravitational pull of all the beautiful galaxies, all the glowing stars, and all the heavy dark matter should act like a cosmic brake, slowly and gently bringing the expansion to a quiet halt. But the universe, in its infinite mystery and boundless wonder, had a completely different story to tell. In the year 1998, two independent teams of astronomers turned their powerful telescopes toward the deep, silent dark to observe distant supernovas. They used these exploding stars as standard candles to meticulously measure the cosmic distances and the rate of expansion across the vast, ancient void. What they found completely shattered our understanding of reality. The universe was not slowing down at all. Instead, it was speeding up. Distant galaxies were moving away from us faster and faster, pushed by an invisible, relentless force, causing space itself to expand at ever-increasing rate. This discovery was so profoundly unexpected that the scientists initially thought they had simply made an error. But as more meticulous data poured in from the cosmos, the staggering result held up. Scientists named this mysterious anti-gravity force dark energy. Rigorous scientific measurements revealed that this unseen energy makes up about 68% of all the energy in the entire universe. It acts as a kind of silent breath, pushing the quantum fields of space apart rather than pulling them together. Its effects become increasingly important over vast stretches of time as the universe expands and ordinary matter becomes more spread out. It might be a fundamental property of empty space itself, something Albert Einstein once proposed as a cosmological constant and later considered his biggest blunder. It might be an entirely new kind of energy field pervading the cosmos, or a gentle sign that our understanding of gravity remains incomplete. Whatever its true nature, dark energy is actively reshaping the ultimate future of the cosmos, dictating a destiny that is deeply melancholy and breathtakingly beautiful. To truly grasp the implications of dark energy, we must stretch our imagination deep into a future measured in billions and trillions of years. As the fabric of space expands faster and faster, distant objects recede from us at ever-increasing speeds. There is a strict physical limit to how fast light can travel through the quantum fields, but there is absolutely no limit to how fast space itself can stretch. Eventually, objects will be carried away by the relentless expansion of space faster than their ancient light can possibly travel toward our telescopes. When that quiet moment arrives, they will vanish completely behind a cosmic horizon, slipping forever beyond our reach. Astronomers calculate that in about 100 billion years, the expansion will accelerate to the point where galaxies outside our local supercluster will begin to disappear over this absolute horizon. The night sky, currently teeming with the faint light of roughly 2 trillion galaxies, will start to slowly, inexorably empty out. One by one, the distant galaxy clusters will fade from view, their light no longer able to cross the expanding void. Within our own tightly bound local group of galaxies, gravity will manage to hold things together for a while longer. Over the next several billion years, our beautiful Milky Way and the neighboring Andromeda galaxy will continue their slow, gravitational dance, eventually merging together into a single, enormous elliptical galaxy. But beyond this merged island of stars, the rest of the universe will eventually slip beyond the cosmic horizon, unreachable and unknowable. If any intelligent observers still exist in that impossibly distant future, their night sky would show only the stars of their own local merged galaxy, set against a backdrop of absolute, unbroken blackness. They would live in profound isolation, cut off from everything else by the relentless expansion of space, floating alone as the eons silently roll by. But even this majestic isolation is not the final chapter of the cosmic story. What exactly happens to a universe that is slowly winding down toward a quiet state known as heat death? Over the next 100 trillion years, the stars that illuminate our universe will slowly and inevitably burn out. The massive blue stars burned through their fuel long ago, collapsing quietly into black holes. Middle-sized stars, much like our warm sun, will gently shed their outer layers to form ghostly nebulas and fade away as cold white dwarfs. Even the smallest, most patient stars in the cosmos, the tiny red dwarfs that burn their hydrogen fuel so slowly they can shine for trillions of years, will eventually exhaust their supplies and go completely dark. Some of these tiny red dwarfs can quietly burn for up to 10 trillion years, roughly 700 times the current age of our universe, providing the very last sources of starlight. But scientists estimate that all star formation in the universe will effectively cease in about 100 trillion years. By that unimaginable point, the primordial gas needed to forge new stars will have been completely used up. No new stars will ever be born. The glorious era of starlight will simply be over. The universe at this late stage will be a deeply dark place, but not an entirely empty one. It will be populated by the silent corpses of stars, slowly cooling white dwarfs, dense neutron stars, and black holes drifting quietly through an ever-expanding, freezing void. Over time scales so unimaginably vast that writing the numbers would fill endless pages. Even these quiet stellar remnants will decay. White dwarfs will cool to near absolute zero after an almost inconceivable amount of time, perhaps 1,000,000 billion years. Over unfathomably long time spans, even the matter making up dead planets may gradually dissolve into radiation. And the black holes, the massive monsters of gravity, will slowly evaporate through a gentle process called Hawking radiation. In the strange world of quantum physics near a black hole, particle pairs are constantly popping into existence from the quantum field. One particle falls in, while the other escapes into the vastness of space, slowly draining energy from the black hole and causing it to shrink. For a supermassive black hole containing tens of billions of solar masses, this evaporation process would take 10 to the 100th power years to finish. That is a 1 followed by 100 zeros, a span of time so overwhelmingly vast that the entire history of the universe from the Big Bang to this moment is not even a microscopic fraction of a rounding error by comparison. Trillions upon trillions of years from now, the very last black hole will radiate away its final bit of energy and disappear in a quiet burst of quantum radiation. There will be nothing left but a thin, freezing mist of elementary particles spreading out infinitely through an ever-expanding, ever-cooling, ever-darkening cosmos. The largest galaxies we have ever found will have dissolved into the endless night. This vision of the ultimate future might initially seem deeply bleak, but there is something strangely, profoundly beautiful about it. It forces us to realize that we exist right now in a brief, brilliant, incredibly special moment of cosmic history, a temporary flowering of light and complexity between the chaotic heat of the early universe and the cold emptiness of the far future. The great astrophysicist Carl Sagan once gently reminded us that the cosmos is all that is, or ever was, or ever will be. Our contemplative journey through these fields is a way to touch that eternity. We are incredibly lucky to exist during this magnificent era of starlight. We are lucky to have evolved intelligence, built powerful telescopes, and pointed them up at the silent dark. In all the vast, stretching history of the cosmos, this moment right now is truly precious because it is the moment when the universe has developed the miraculous ability to look at itself and quietly wonder. The very same quantum fields that will one day stretch into a freezing eternity are the exact same fields that currently vibrate to form your beating heart, your conscious mind, and the brilliant stars that light up our night sky. We are not separate from the great cosmic drama. We are an intimate, beautiful part of it. The universe exploring its own infinite mysteries from within. But as we reflect on this grand, sweeping timeline of the cosmos, from its fiery birth to its freezing, silent end, a profound question gently rises to the surface. If space is expanding, what exactly is it expanding into? If the quantum fields stretch forever, where did they originally come from? To truly appreciate the journey we are on, we must turn our gaze backward, past the ancient stars, past the cosmic microwave background, and venture to the very beginning of time itself. We must gently explore the primordial spark that set this magnificent, invisible ocean in motion. Have you ever closed your eyes in a quiet room and tried to gently reach back into the very earliest memories of your childhood? You might catch a fleeting glimpse of a warm afternoon or a soft voice, but the edges are blurred, fading softly into an inaccessible darkness. Our minds can only stretch so far back into our own personal history before we meet the silent wall of our beginnings. The universe, in its infinite grandeur, has a memory too. It has a beginning, a primordial dawn that set the magnificent clockwork of the cosmos into motion. Unlike our fading human memories, the universe has perfectly preserved the evidence of its birth, leaving it scattered across the freezing, silent dark for us to gently uncover. To truly understand the invisible quantum fields that quietly sustain our beating hearts today, we must journey backward through the vast, sweeping corridors of time. We must rewind the relentless expansion of space, pulling the distant galaxies closer together, compressing the unfathomable distances, and plunging into an era long before the first stars ever dared to ignite. We are traveling back roughly 13,800,000,000 years, approaching a moment of such profound, intense mystery that our mathematical equations begin to gently break down under the sheer, unimaginable extremity of the physics involved. When we try to picture the birth of the universe, our common sense often paints a misleading picture. We intuitively imagine a colossal, violent explosion happening inside an endless, empty void of pre-existing space, like a magnificent firework detonating in the dark night sky. But the rigorous mathematics of general relativity and quantum mechanics tell us a completely different, far more mind-bending story. The Big Bang was not an explosion that happened inside space. It was the explosion of space itself. Before this primordial moment, there was no empty container waiting to be filled. There was no time to tick forward and no distance to measure. Space and time, as inextricably linked dimensions, were intimately bound together in a state of infinite density and unimaginable heat. All the vast emptiness we see today, all the continuous quantum fields that ripple to form the stars, the planets, and our own fragile bodies, were compressed into a region so incredibly microscopic that it defies human comprehension. In that fiery, absolute beginning, the invisible ocean of the quantum fields was not a calm, quiet surface. It was a violently boiling, unified storm of pure energy. In the very first tiny fraction of a single second after the universe began to expand, something truly miraculous happened. Physicists call this breathtaking event cosmic inflation, in a period of time so incomprehensibly brief that writing it out would require dozens of zeros after a decimal point. The fabric of space itself stretched outward at a speed far surpassing the speed of light. You might gently wonder how anything can move faster than light, since we established earlier that this is the absolute speed limit of the cosmos. But the profound truth is that while no particle can travel through space faster than light, space itself can stretch and expand at any speed it pleases. During this violent, magnificent stretching, the microscopic, seething quantum fluctuations, those tiny, fleeting virtual particles popping in and out of existence, were suddenly grabbed by the expanding fabric of reality. They were stretched and frozen across macroscopic distances, transforming from microscopic quantum whispers into colossal, universe-spanning variations in density. This is perhaps one of the most beautiful realizations in all of modern science. The grandest, most massive structures in the entire universe today, the giant clusters of galaxies and the sprawling, invisible web of dark matter, are actually just the magnified, frozen echoes of tiny quantum ripples that existed when the universe was less than a trillionth of a second old. The macro is intimately, fundamentally born from the micro. As the inflation slowed to a more steady, patient pace, the universe continued to expand and gently cool. The universe at that time was very different from what we see today. For the first 380,000 years of its existence, the cosmos was an incredibly dense, opaque fog of scorching plasma. The quantum fields were vibrating with such intense, chaotic energy that electrons could not settle down to orbit atomic nuclei. Every time a photon of light tried to travel through this blazing inferno, it would instantly crash into a free-floating electron, trapping the light in a relentless, glowing, impenetrable haze. If you could somehow stand in the universe at that time, you would see absolutely nothing but a blinding, uniform, white-hot glow in every single direction. But the universe is a system of profound, patient evolution. As space continued its relentless expansion, the temperature slowly dropped. And then, at a very specific, beautiful moment in cosmic history, the universe cooled just enough for a profound transformation to take place. The seething, chaotic energy finally dipped below a critical threshold. Suddenly, the electrons slowed down enough to be gently captured by the protons. The very first atoms of hydrogen and helium were born. And in that magnificent instant, the dense, glowing fog lifted. The electrons were now safely bound within atoms, leaving the vast spaces between them clear and open. For the very first time in the history of existence, light was free to travel. The story begins about 13 billion years ago, not long after the Big Bang itself. There were no galaxies yet, just vast clouds of hydrogen and helium gas left over from the first few minutes of cosmic history. This ancient primordial burst of photons has been traveling through the expanding cosmos ever since, stretching and cooling as the universe expands. Today, this first light washes over our planet in a continuous, quiet shower of invisible microwave radiation. Scientists call it the cosmic microwave background. When brilliant instruments like the European Space Agency's Planck satellite gaze out into the deepest, coldest depths of the cosmos, they capture the incredibly faint, ancient glow of this exact moment. When we look at the intricate maps of the cosmic microwave background, we are quite literally looking at the baby picture of the universe. We are seeing the gentle, quiet ripples of those original quantum fluctuations, the microscopic seeds that would eventually grow into everything we know and love. To deeply contemplate this ancient history is to experience a profound sense of connection and awe. The renowned astrophysicist Neil deGrasse Tyson once remarked that we are biologically connected to every other living thing in the world. We are chemically connected to all molecules on Earth, and we are atomically connected to all atoms in the universe. This is not just a comforting sentiment. It is rigorous, undeniable scientific truth. The fundamental quantum fields that permeate your body right now, the fields that vibrate to create the complex chemistry of your thoughts and the warm beating of your heart, have existed since that first fiery instant. They were stretched and distorted during the magnificent epoch of cosmic inflation. They felt the sudden, liberating clearing of the fog when the first atoms finally formed in the quiet dark. You are an intricate, highly evolved, localized expression of a universe that has been slowly, patiently unfolding for billions of years. The silent, invisible ocean of potential that surrounds us has a history, and that history is written into the very fabric of our being. This profound realization deeply shifts our perspective on what we actually are. We are not just wandering passengers floating on a random rock through an empty, uncaring void. We are the universe itself, made of recycled stardust, brought to life through billions of years of patient cosmic evolution, capable of looking back at the sky and gently wondering at our own ancient origins. We are the quantum fields organized into astonishing, self-aware complexity. Yet, as we trace this majestic journey from the fiery Big Bang to the complex beings we are today, we must pause to consider the invisible rules governing this entire magnificent process. How do the quantum fields know exactly how to interact? Why do electrons repel each other, while the protons in a nucleus hold tightly together? What are the invisible threads of communication allowing the universe to build such intricate, stable structures? To truly understand the architecture of our reality, we must shift our focus from the particles themselves to the silent messengers that travel constantly between them. We must dive into the profound mysteries of the fundamental forces of nature. As we continue this contemplative journey, we will explore how the universe communicates with itself and how these delicate interactions create the magnificent reality we experience every day, binding the cosmos in an eternal, silent embrace. Have you ever held two smooth, heavy magnets in your hands, slowly bringing them closer and closer together, only to feel a sudden, invisible resistance pushing firmly back against your fingers? You look into the space between them, and you cannot see anything at all. The air is completely clear, transparent, and empty. Yet, there is a profound, undeniable physical presence there, a quiet, invisible barrier that absolutely refuses to be crossed. We experience this invisible push and pull in our everyday lives, but we rarely pause to deeply wonder what is actually happening in that silent space. We are so deeply accustomed to a macro world where making things move requires a physical touch, a gentle push, a soft tap, a firm grasp. But the quantum universe, in its infinite mystery and breathtaking elegance, operates on a completely different, far more majestic set of rules. At the most fundamental level of reality, true physical contact is an absolute illusion. When you rest your hand on a solid wooden table, your skin is not actually touching the wood at all. Instead, The invisible quantum fields of your atoms are communicating with the invisible quantum fields of the table, exchanging silent, ghostly messages that create the sensation of pressure and solidity. To truly understand the hidden architecture of our cosmos, we must gently shift our perspective from the solid particles themselves to the invisible threads of communication that bind them together. We will explore the four fundamental forces of nature, the ancient rules governing every interaction in the vast universe, from the microscopic heart of an atom to the majestic collision of entire galaxies dancing in the dark. Let us begin with the force that shapes almost everything you experience in your daily conscious life: electromagnetism. This is the invisible hand that creates light, electricity, and the magnetic fields that guide compasses toward the north. In the beautiful, rigorously tested mathematical framework of quantum field theory, forces are not simply mysterious, inexplicable pulls or pushes happening magically across empty space. Instead, they are the profound result of particles exchanging tiny, ephemeral packets of energy, which brilliant scientists call gauge bosons. For the magnificent electromagnetic force, this silent messenger is the photon. Every single time two electrons gently repel each other, they are actually tossing invisible, virtual photons back and forth across the quantum void. It is a continuous, microscopic game of catch, happening billions of times every single second. This magnificent force is exactly what holds the electrons in their delicate, swirling orbits around the dense nucleus of an atom. It is the very reason matter has complex chemistry, the beautiful reason atoms can bond together to form the liquid molecules of water, the solid structure of ancient stone, and the fragile, intricate double helix of DNA inside your beating heart. Without this continuous, invisible conversation happening in the quantum field, all the atoms in your physical body would instantly dissolve, drifting away into the silent dark. Yet, as powerful and essential as electromagnetism is, it presents a profound, beautiful paradox when we look deep into the absolute center of the atom, deep within the tiny, incredibly dense nucleus of every single atom in the universe. Protons are packed tightly together in a remarkably small space. Because protons all carry a positive electrical charge, the electromagnetic force demands that they should repel each other with terrifying, explosive violence. If electromagnetism were the only force at play in the cosmos, atomic nuclei simply could not exist. They would violently tear themselves apart the very instant they tried to form in the primordial universe. But the cosmos harbors a deeper, far more powerful secret. There is another quantum field, another invisible ocean of interaction, known as the strong nuclear force. This is the absolute strongest force in the known universe, roughly 100 times stronger than electromagnetism. Its dedicated messenger particles are wonderfully named gluons, because they act like an unbreakable, invisible cosmic glue. These gluons fly back and forth between the tiny quarks that make up protons and neutrons, binding them together with a grip so incredibly fierce that nothing in our everyday macroscopic world can possibly break it. The strong force operates only over unfathomably microscopic distances, practically vanishing into nothingness if the particles move even a tiny fraction of a nanometer apart. But within that microscopic hidden realm, it is the undisputed, majestic ruler. It is the quiet, ancient strength that maintains the absolute stability of ordinary matter, the hidden anchor that allows the universe to build structure, complexity, and life in the silent void. But a universe built exclusively of unbreakable bonds would be a static, unchanging, and ultimately lifeless place. For the cosmos to truly evolve, for stars to shine brilliantly, and complex chemistry to flourish on rocky planets, there must be a subtle mechanism for transformation. Enter the weak nuclear force, the quiet, patient agent of change in the quantum realm. Unlike the incredibly strong force that strictly binds things together, the weak force has the profound ability to change one type of fundamental particle into an entirely different type. It operates over distances even smaller than the strong force, utilizing heavy, sluggish messenger particles known to physicists as W and Z bosons. This gentle, almost imperceptible force is uniquely responsible for radioactive decay, a process that might initially sound destructive, but is actually deeply, fundamentally essential for the grand machinery of the cosmos. It is the subtle, weak force that allows protons to transform into neutrons in the incredibly dense, blazing cores of stars. Without this crucial transformation, nuclear fusion would be completely impossible. Our warm, glowing sun would not be able to burn hydrogen into helium and heavier elements, just like stars do everywhere. The tiny red dwarfs, the smallest stars in the universe, would not be able to burn their fuel so slowly that they can shine for trillions of years. The weak force is the invisible, essential spark that patiently ignites the stars, flooding the vast universe with life-giving light and energy. When you look out into the quiet starlit night, or when you simply look down at your own resting hands, you are witnessing the exquisite, perfect balance of these four fundamental forces. The strong force holds your atomic nuclei safely together. The electromagnetic force binds your atoms and molecules together. The weak force allows the distant sun to bathe you in warm light. And gravity holds you safely on the surface of our spinning blue planet. The universe did not have to be this way at all. If the fundamental constants of physics were even slightly different, if gravity were a little stronger, or the nuclear forces a little weaker, stars and galaxies might never have formed. The universe might have collapsed back on itself moments after the Big Bang, or expanded so fast that matter never clumped together. Instead, we live in a universe where physical laws allow for the formation of stars, planets, galaxies, life, and mind. We exist in a breathtaking, mathematically elegant masterpiece of invisible interactions. The quantum fields do not simply exist in cold isolation. They dance together in a continuous choreography strictly dictated by these four ancient rules. Yet, as our brilliant scientists peer ever deeper into the complex mathematics of these interconnected fields, a profound, beautiful thought has begun to slowly emerge. What if these four seemingly distinct forces are not actually fundamentally different things at all? What if, in the incredibly hot, dense, chaotic moments immediately following the primordial Big Bang, all these distinct forces were perfectly united into a single, elegant master force? This quest gently challenges our basic understanding of separation and distance, reminding us that at the deepest level, absolutely everything in the universe might simply be a slightly different manifestation of the exact same underlying reality. As we continue our contemplative journey together, we must prepare to slowly leave the comforting world of localized forces and distinct particles behind, and step into a realm where the very concepts of space and time begin to completely lose their meaning. We will explore a quantum phenomenon so deeply strange and so profoundly beautiful that even Albert Einstein himself struggled to fully accept its reality. We will gently uncover the invisible, instantaneous threads that silently connect particles across the vast, empty reaches of the cosmos. We will dive together into the mind-bending, infinite mystery of quantum entanglement. Have you ever felt a sudden, inexplicable connection to someone physically very far away? We usually brush these moments off as mere coincidences, tiny quirks of human intuition. Common sense tells us we are isolated beings, divided by miles of empty space, and any influence must patiently travel across that distance. If you want to speak, your voice travels as a wave of compressed air. Absolute separation seems to be a fundamental law of nature, but as we dive deeper into the invisible ocean of the quantum field, we discover the universe has a far more poetic way of organizing itself. Deep in the mathematical heart of reality, distance is an illusion. There exists a phenomenon so deeply counterintuitive, it challenges everything we thought we knew about space and separation. We are going to gently explore a mystery that puzzled the most brilliant minds of the 20th century. We are going to encounter quantum entanglement. To appreciate the wonder of this mystery, we must remember a strict rule of the cosmos. Nothing can travel faster than the speed of light. Albert Einstein built his magnificent theory of relativity upon this unshakable foundation. The speed of light, roughly 186,000 miles per second, is the ultimate cosmic speed limit. If the sun were to vanish right now, we would not know about it for roughly 8 minutes, because that is exactly how long it takes for the final ancient photons of light to cross the freezing void to Earth. Information takes time to travel. This is the bedrock of local reality, the comforting idea that an object can only be directly influenced by its immediate surroundings. But the quantum fields, in their infinite complexity, do not strictly care about our comforting notions of reality. Imagine we carefully create two tiny subatomic particles, born together from the exact same energetic event in a meticulously controlled laboratory. Because they are born together, their properties are intimately linked. They become entangled. In the strange world of quantum mechanics, before you measure a particle, it does not have a definite state. It exists in a quiet haze of probability, a superposition of all possible outcomes. It is only when you force it to interact with a measurement device that it settles into a defined reality. Now, suppose we gently separate these entangled photons. We leave one in our quiet laboratory on Earth and send the other on a long, silent journey to the edge of the observable cosmos, billions of light years away. According to everything we know about local reality, they should be completely independent. But the universe holds a breathtaking surprise. If we measure the photon on Earth, causing it to suddenly collapse out of its quiet haze of probability and choose a definitive state, say, its quantum spin points upward, something absolutely miraculous happens to its partner on the other side of the universe. In that infinitesimal fraction of a moment, with exactly 0 time delay, the distant photon instantly assumes the complementary state, pointing its spin downward. It does not matter if they are separated by 10 feet or 10 billion light years. The distant particle simply knows what has happened to its partner, and it reacts instantaneously. There is no time for a signal to travel between them. There is no invisible messenger particle crossing the vast void at the speed of light. The communication is perfectly instantaneous. When Albert Einstein first confronted the rigorous mathematics predicting this phenomenon, he was deeply unsettled. He famously called it spooky action at a distance, believing the equations of quantum mechanics must simply be incomplete. He argued the particles must have secretly agreed on their states the moment they were created, carrying hidden variables with them on their long journey, much like a pair of gloves separated into 2 boxes. If you open one box and find a left glove, you instantly know the other contains the right glove. not because they magically communicated, but because they were already left and right to begin with. It was a logical explanation that perfectly preserved the absolute speed limit of light. For decades, it remained a gentle philosophical debate between the brilliant minds of theoretical physics who yearned to understand the silent machinery of existence. But science is a relentless pursuit of empirical truth. In the 1960s, a brilliant physicist named John Bell devised a complex mathematical theorem that could finally test whether Einstein's hidden variables were real. In subsequent decades, leading to a magnificent Nobel Prize in Physics in 2022, scientists like Alain Aspect, John Clauser, and Anton Zeilinger conducted breathtaking precision experiments to test Bell's theorem. They fired entangled particles through intricate fiber optic cables, sent them across the quiet air between mountaintops, and beamed them from the Misch's satellite, orbiting in the freezing vacuum of space, down to ground stations separated by over 1,200 kilometers. The results were beautifully undeniable. Einstein was wrong. There are no hidden variables. Spooky action at a distance is demonstrably real. How do we make sense of this profound cosmic paradox? How can two things separated by vast distances react as if they are right next to each other? The answer gently forces us to completely reimagine the invisible architecture of the quantum field. When two particles become entangled, they essentially cease to be two distinct, separate entities. They become a single, unified quantum system, an invisible mathematical whole beautifully spread out across the fabric of space. We look through our powerful instruments and see two particles, but the universe sees only one continuous, unbroken reality. When you touch one, you are instantly touching the other, because in the deep, silent machinery of the cosmos, they were never truly separated. Distance simply does not exist for an entangled system. Space itself, the vast theater we thought contained the universe, might actually be an illusion. Some advanced theoretical physics today suggests an idea so breathtaking that it requires a moment of deep, contemplative silence to truly absorb. Scientists are beginning to mathematically explore the possibility that the very fabric of space-time is literally woven together by the delicate threads of quantum entanglement. In this beautiful vision of reality, space is not an empty, passive void. It is an active, emergent property, a magnificent tapestry woven from trillions of invisible quantum connections. The reason 2 points in space feel physically close to each other is simply because the quantum fields in those locations are highly entangled. The universe holds itself together through the quiet, unseen embrace of these mysterious mathematical connections. When we gaze up at the vast night, we are looking at a single, infinitely complex organism, vibrating as one beautifully unified whole. This brings a profound, gentle shift in how we perceive our own existence. Think back to the primordial moment of the Big Bang, roughly 13,800,000,000 years ago. In that fiery, infinitely dense instant of creation, absolutely all the matter and energy in the entire universe was compressed together into a space infinitely smaller than a single atom. Every single quantum field, every solitary particle that would eventually become the swirling galaxies, the ancient stars, and the complex atoms of your body were intimately, violently interacting in that primordial soup. They were born together. Therefore, in a very real, mathematically rigorous sense, the entire universe might still be fundamentally entangled with itself. The particles in your beating heart are forever linked to the silent void between the stars. You are deeply, permanently woven into the invisible fabric of the cosmos. As we drift peacefully through these majestic concepts, letting the profound strangeness of the quantum realm gently wash over us, we find a deep, beautiful comfort. The universe is not a cold, disconnected clockwork ticking away in the dark. It is a warm, deeply entangled web of intimate relationships. Every action, every quiet whisper of energy in the quantum field is part of a grand cosmic symphony where every instrument instantly knows what every other instrument is playing. We are never truly alone because the atoms constructing our minds are holding hands with the rest of the universe. But this interconnectedness naturally leads us to yet another beautiful mystery. If reality itself seems to wait in a quiet haze of probability until something interacts with it, what exactly is the role of the conscious observer? As we gently continue our journey, we must venture deeper into the mind-bending quantum world to explore how observation forces the universe to choose a solid reality. Have you ever quietly walked through a thick, ancient forest and wondered if the towering trees still exist when you are no longer looking at them? It is a gentle, playful question we often ask children, a simple philosophical riddle meant to spark the imagination. Common sense firmly and comfortably assures us that the physical world is permanent and stubbornly independent of our gaze. The heavy mountain remains precisely where it is, whether we look at it or not. The pale moon continues its silent, orbital dance in the dark, even when our eyes are closed in sleep. For centuries, brilliant scientists like Isaac Newton and Albert Einstein believed in this objective, deterministic reality, a universe that ticks away like a grand independent clockwork, entirely indifferent to whether anyone is watching. But as we venture deeper into the infinite, mysterious depths of the quantum field, this comforting certainty begins to gently dissolve. The universe, it seems, has a breathtaking secret regarding the very nature of reality itself. In the microscopic, quiet realm of subatomic particles, the act of simply looking at something fundamentally changes what that something actually is. To truly understand this mind-bending paradox, we must explore the most famous and deeply unsettling experiment in the entire history of quantum physics. We must gently illuminate the profound mystery of the double-slit experiment. Let us imagine a deeply quiet, entirely dark laboratory, perfectly isolated from the chaotic vibrations of the outside world. Inside this silent room, scientists have meticulously set up a beautifully simple apparatus. There is an electron gun, a highly precise device designed to fire tiny individual electrons, one by one, toward a solid barrier. In the absolute center of this barrier, there are two extremely narrow, parallel slits. Behind the barrier sits a highly sensitive detection screen that glows with a tiny, brief flash of light, exactly where an electron strikes it. If the fundamental building blocks of our reality were simply solid little spheres like microscopic marbles, we would logically expect them to pass through the slits and form two distinct parallel bands on the screen behind them. That is exactly what happens when you throw tiny pebbles at a fence with two missing wooden boards. But the quantum field, holding the ancient secrets of the cosmos, does not play by the simple rules of our macroscopic world. When brilliant physicists actually perform this experiment, firing electrons through the two narrow slits, the screen reveals something absolutely astonishing. Instead of two simple bands, a complex alternating pattern of bright and dark stripes slowly emerges in the quiet dark. This beautiful, complex design is known as an interference pattern, and it is the unmistakable, rigorous scientific signature of overlapping waves. How can a single, solitary electron, fired completely alone through the silent vacuum, possibly create a wave pattern? To understand this, we must gently let go of our everyday intuition. The electron is not a solid marble at all. As it travels through the silent void of the laboratory, it exists as a ripple in the invisible electron field, a ghostly, mathematical wave of pure probability, perfectly described by the legendary Schrödinger equation. This invisible wave approaches the barrier, simultaneously passes through both the left slit and the right slit, and then beautifully interferes with itself on the other side, just like gentle ripples overlapping on the surface of a quiet pond. The electron is not in one specific defined place. It is in a profound state of quantum superposition, exploring every possible path through the universe at the exact same time. It only becomes a localized, solid point of impact at the exact moment it strikes the screen. This alone is a breathtaking realization, revealing that the solid matter composing our bodies actually stems from ethereal waves of potential. But the true, deep mystery of the cosmos reveals itself when scientists try to outsmart the quantum field to see exactly what is happening in the dark. Driven by the boundless human need for understanding, physicists decided to place a tiny, highly advanced measuring device right next to the two slits. They simply wanted to peek at the universe's hidden machinery, to quietly record exactly which slit the individual electron was actually choosing to pass through. They fired the electrons again, one by one, through the perfect silence of the vacuum chamber. The detector quietly recorded each passing particle, confirming that an electron went through either the left slit or the right slit, never both. But when the scientists looked at the final screen, the magnificent, beautiful interference pattern was completely, inexplicably gone. In its place were just two simple, distinct bands, exactly like the macroscopic pebbles. By simply placing a detector there, by quietly extracting information from the system and asking the universe for a definite answer, the entire fundamental nature of the electron completely changed. It instantly stopped behaving like a mysterious wave of infinite potential and abruptly collapsed into a stubborn, localized particle. The mere act of observation forced the quantum field to abandon its ghostly superposition and choose a single, solid reality. This staggering, scientifically rigorous phenomenon is widely known as the collapse of the wave function, first formulated in the 1920s by brilliant minds like Niels Bohr and Werner Heisenberg in what is called the Copenhagen interpretation. It remains one of the most profound, unresolved mysteries in all of modern science. It gently suggests that the universe does not fully exist in a definite, solid state until it is observed or interacted with. Before measurement, a particle is a quiet haze of mathematical possibilities, suspended patiently in the vast, silent ocean of the quantum field. It is only through the intimate act of interaction, the exchange of information, that reality crystallizes into being. This realization forces us to ask a deeply existential question that blends physics with philosophy. What exactly counts as an observer? Does it require a conscious human mind looking through a complex instrument in a quiet laboratory? Or is a simple mechanical interaction between a photon of light and a wandering atom enough to force the universe to make a concrete choice? While physicists continue to debate the rigorous mathematical nuances of decoherence, the profound philosophical implication remains beautifully, startlingly clear. We are not just passive, isolated spectators sitting in the dark theater of the cosmos. We are active, essential participants in the continuous, unfolding creation of reality itself. The renowned theoretical physicist John Archibald Wheeler gently propose that we actually live in a participatory universe. In this breathtaking, paradigm-shifting vision, the cosmos and the observer are locked in an eternal, intimate embrace. The universe gives rise to conscious beings through billions of years of patient evolution, and through the quiet act of observation, those conscious beings give definitive, localized reality back to the universe. When you walk outside tonight and look up at the glowing stars scattered across the ancient, unfathomable night sky, your eyes are gently absorbing ancient photons that have traveled across billions of light years of silent, freezing, empty space. For their entire immense journey from a distant galaxy to your exact location, those photons existed as spreading waves of probability in the electromagnetic field. But at the exact miraculous moment they touch the delicate retina of your eye, they instantly collapse into definite particles of energy, ending their billion-year journey in a tiny, quiet spark of solid reality within your mind. You, in that beautiful, silent moment of conscious perception, are actively finalizing a majestic cosmic process that began long before the Earth was even born. To deeply contemplate this profound connection is to find a deep sense of peace and belonging in the vastness of the universe. We, as human beings, often feel incredibly small and insignificant when faced with the infinite scale of the cosmos, the trillions of swirling galaxies, and the unfathomable, stretching distances of cosmic time. But the rigorous mathematics of quantum mechanics gently whispers a completely different truth. It tells us that our presence absolutely matters. The consciousness that flickers quietly within your mind is deeply, fundamentally entangled with the very architecture of reality. The invisible quantum fields that permeate the silent dark rely on interactions, on measurements, on the gentle, defining touch of observation, to weave the magnificent, heavy tapestry of the physical world. Your conscious experience is not a random accident. It is a fundamental, integrated property of how the universe operates. You are the universe beautifully, quietly experiencing itself, collapsing infinite mathematical possibilities into a single, breathtaking moment of now. Yet, this profound realization naturally brings us to the edge of an even more staggering mystery, one that stretches the limits of our imagination. If a fundamental particle exists as a wave of infinite, overlapping possibilities before it is observed, and our quiet observation forces it to choose just one single path to become real, what exactly happens to all the other possibilities? Where do all the unchosen paths go? When the quantum field collapses to create the reality we see, does the rest of that vast, invisible potential simply vanish into absolute nothingness? Or does the universe harbor a structural secret even more magnificent and deeply unsettling than anything we have explored so far? To answer these profound existential questions, we must gently push beyond the safe, comforting boundaries of our single, observable reality. We must prepare to stretch our minds across the infinite, echoing expanse of the unknown. As we continue this quiet, contemplative journey together, we will explore a mathematically rigorous, breathtaking interpretation of quantum mechanics that suggests every single possibility actually truly happens. We are going to venture deep into the silent, sprawling, infinite architecture of the multiverse. Have you ever stood at a quiet crossroads on a foggy morning, faced with a simple choice between two paths, and gently wondered what your life would be like if you had taken the other route? We experience our lives as a single, unbroken timeline, a solitary thread woven through the vast unfolding tapestry of time. Every single day we make thousands of tiny, seemingly insignificant choices. We turn left instead of right. We pause for a quiet moment to look at a bird, or we simply keep walking. Common sense tells us that once a choice is made, the unchosen path simply vanishes into the silent ether of what might have been, completely erased from existence. But in the strange, mathematically rigorous world of quantum mechanics, the universe might be far more generous and infinitely more complex than our solitary human experience suggests. To answer the profound mystery we uncovered in our previous exploration, the question of where the unchosen quantum possibilities go when we observe a particle, we must gently open our minds to an idea so breathtakingly vast that it challenges the very definition of reality. We are going to explore the quiet, branching, infinite architecture of the many worlds interpretation. In the 1950s, a brilliant, deeply imaginative physicist named Hugh Everett III looked at the mathematics of quantum mechanics and noticed something peculiar. The famous Schrödinger equation, which beautifully describes how the quantum wave of probability evolves over time, does not actually contain any mathematical mechanism for a collapse. The idea that the wave function suddenly shrinks into a single, solid point of reality the moment we look at it was added later by physicists trying to make the math match our everyday, localized experience. Everett simply asked a radical, mathematically pure question. What if we do not add the collapse? What if the wave function never actually collapses at all? What if the quantum mathematics are telling us the exact, literal truth about how the cosmos operates? The answer he discovered is profoundly beautiful and deeply unsettling. If the wave function never collapses, then every single possible outcome of a quantum event must actually happen. They just happen in completely separate, newly branched realities. Let us return for a quiet moment to our dark, silent laboratory and the magnificent double-slit experiment. When we fire a single electron toward the two narrow slits, it exists as a spreading wave of pure probability. It has the potential to go through the left slit, and it has the exact same potential to go through the right slit. According to the many worlds interpretation, when the electron reaches the barrier and interacts with it, the universe does not force it to make a choice. Instead, the universe itself gently and silently splits into two distinct, separate, and equally real versions. In one beautifully complete universe, the electron travels through the left slit. In the other, equally complete universe, the identical electron travels through the right slit. Because you, the quiet observer, are also made of quantum fields, you split along with the universe. There is now one version of you who saw the electron go left, and another, equally conscious version of you who saw it go right. Both versions feel completely real. Both versions remember the exact same past, but from that microscopic moment onward, their futures will gently, forever diverge. The sheer, unfathomable scale of this realization requires a deep, meditative pause to truly absorb. We are not just talking about a few parallel universes existing side by side. We must consider the magnificent, terrifying reality of the quantum field itself. Everywhere in the universe, at every single microscopic fraction of a nanosecond, countless trillions of quantum events are taking place. Virtual particles are endlessly bubbling into existence and annihilating in the dark vacuum. Electrons are constantly shifting their orbits within atoms. Radioactive elements are making microscopic, probabilistic choices to decay or remain stable. According to the mathematics of this interpretation, every single time one of these quantum events has multiple possible outcomes, the entire fabric of reality branches. It is a quiet, continuous, infinite explosion of new universes, a magnificent, ever-growing fractal tree of existence expanding into the silent dark. Our specific universe, the one you and I are currently experiencing together right now, is just one single, impossibly thin branch on an infinitely dense, beautifully complex canopy of cosmic reality. The sheer scale of this invisible mathematical structure makes the billions of glowing galaxies we can see with our most advanced telescopes seem like a single grain of sand on a beach that stretches into absolute infinity. The universe is not a single, lonely room. It is an endless, majestic mansion of infinite corridors. And new rooms are being built every single time a quantum particle interacts with another. This idea completely shatters our traditional, comforting understanding of space and existence. Where are all these other universes? They are not floating billions of light years away in the freezing void of our own space. They exist right here, right now, perfectly superimposed over our own reality, occupying the exact same physical space, but completely, fundamentally separated from us by the mathematical structure of quantum mechanics. They are in a state physicists call orthogonal. They simply cannot interact, communicate, or interfere with one another once the branching has occurred. You cannot build a spaceship and travel to them, and you cannot tune a radio to hear their silent broadcasts. They are infinitely close, yet absolutely, eternally inaccessible. We are forever trapped within the quiet confines of our own specific, singular branch of reality, floating silently along one unique timeline through an endless ocean of infinite variations. To deeply contemplate this infinite multiverse is to experience a profound, gentle shift in how we view our own lives. There is a deeply comforting, almost poetic beauty in the idea that every single possibility allowed by the strict laws of physics is actively playing out somewhere in the vast, unseen architecture of existence. Somewhere out there, in a branch separated from ours by billions of tiny quantum choices, there is a universe where the ancient asteroid that wiped out the dinosaurs gently missed the Earth, allowing massive reptiles to continue their reign. There is a quiet universe where the Earth never formed at all, leaving the solar system a dusty, barren ring of primordial rock. And beautifully, overwhelmingly, there are countless, infinite versions of you. There is a version of you who made every single possible different choice in your life. There are branches where you pursued a different career, where you lived in a different distant city, or where you spoke a completely different language. Every single time you faced a difficult decision and chose one path, another version of you, equally real and equally conscious, gently walked down the other. This realization does not render our specific choices meaningless. Rather, it elevates the profound beauty of our current conscious experience. You are the unique accumulation of billions of years of cosmic history and trillions upon trillions of specific, microscopic quantum choices that led exactly to this quiet, contemplative moment. Out of an infinite number of possible realities, this is the one you are actively experiencing. The universe you see around you, with its glowing stars, its heavy, comforting gravity, and its delicate, intricate biology, is a magnificent, singular masterpiece that you are intimately woven into. The great theoretical physicist Stephen Hawking spent much of his brilliant life exploring the mathematical edges of these infinite universes, gently reminding us that while the math might suggest an infinite number of realities, the only one that truly matters to our conscious minds is the one we currently inhabit. We must learn to find peace and wonder in the specific, beautiful branch of reality we are fortunate enough to experience. You are exactly where you are supposed to be, because the laws of physics brought you to this precise moment. Every sorrow, every joy, every quiet moment of reflection is a necessary, beautiful part of this specific mathematical thread. We can look out into the silent dark of the night sky and find deep comfort in knowing that the cosmos is vast enough, mysterious enough, and beautiful enough to contain every single possibility. But as we accept this majestic, infinite branching of the quantum fields, a new, deeply perplexing question quietly emerges from the shadows. If the universe is constantly, relentlessly splitting into an infinite number of parallel realities, what is the fundamental nature of the underlying stage where all this magnificent branching takes place? The space and time we experience in our everyday lives seem smooth, continuous, and completely empty. But if we were to zoom in past the tiny atoms, past the swirling electrons, and look at the very fabric of space itself at the absolute smallest conceivable scale, what would we actually see? We must prepare to leave the comforting, smooth world of particles and branches behind and dive into a realm where space and time completely lose their meaning, breaking down into a chaotic, boiling, microscopic storm. As we gently continue our journey, we will explore the absolute smallest limit of reality, the invisible, pixelated foundation of the cosmos. We will venture into the mind-bending, ancient mystery of quantum foam and the Planck length. Have you ever gently traced your fingers across the surface of a perfectly polished mirror or a calm, undisturbed pool of water? To our human senses, the surface feels flawlessly smooth, a continuous, unbroken plane of quiet perfection. We naturally assume that the very fabric of the universe, the empty space that holds the glowing stars and the silent void between the galaxies, shares this elegant, continuous smoothness. Albert Einstein, in his magnificent theory of general relativity, beautifully describes space-time as a vast, flexible sheet, a smooth trampoline that gently curves and bends under the heavy weight of massive planets and brilliant suns. But as we have learned on this contemplative journey together, the cosmos is a master of profound disguise. The comforting smoothness of our everyday reality is merely a magnificent illusion, a trick played on us by the limits of our perception. To truly understand the invisible foundation of the quantum field, we must take a deep, quiet breath and zoom in far beyond the familiar realm of atoms and quarks. We must prepare to stretch our imagination to the absolute limit of physical reality, a place where the comforting concepts of distance, duration, and even space and time themselves begin to violently, beautifully break down. We are going to explore the ancient, seething mystery of quantum foam and the incomprehensible scale of the Planck length. Imagine taking a single, quiet inch of empty space and magnifying it until it is the size of the entire observable universe. Now, imagine taking a single microscopic inch of that newly expanded space and magnifying it again to the exact same staggering scale. You would have to repeat this mind-bending process of extreme magnification many times before you finally reached the foundational grid of the cosmos. This absolute smallest unit of measurement in physics is called the Planck length, named after the brilliant physicist Max Planck. It is roughly 1.6 times 10 to the power of negative 35 meters. Writing this number out would require a zero followed by a decimal point, followed by 34 more zeros before you finally reach a single, solitary number 1. It is a scale so profoundly impossibly tiny that if a single atom were suddenly expanded to the size of the entire visible universe, the Planck length would still only be about the height of an average human being. In this deeply hidden, microscopic realm, the elegant, predictable rules of classical physics completely dissolve. Even the familiar ghostly ripples of the quantum fields we explored earlier can no longer be described in the same gentle way. When brilliant physicists try to mathematically combine the smooth, continuous equations of Einstein's gravity with the chaotic, bubbling probability of quantum mechanics at this incomprehensible scale, the mathematics explode into absolute chaos. The renowned theoretical physicist John Archibald Wheeler, a man with a beautiful gift for capturing the deep poetry of the cosmos, first realized what the equations were trying to tell us in the 1950s. He proposed that if you look closely enough at the fabric of space-time, it is not a smooth, empty canvas at all. Instead, it is a violently boiling, endlessly churning ocean of pure, furious energy. He named this profound hidden reality quantum foam. In this microscopic, seething storm, space and time are not permanent, stable dimensions. They are constantly fracturing, tearing apart, and stitching themselves back together in tiny fractions of a single second. Microscopic wormholes, tiny bridges connecting completely different parts of the universe, might be endlessly popping into existence and vanishing just as quickly in the dark. The very concepts of up and down, before and after, completely lose all meaning in this frothing, chaotic sea. To deeply contemplate the reality of the quantum foam is to experience a profound sense of existential wonder. The solid, comforting chair you're resting in right now, the quiet ground beneath your feet, and the seemingly empty air you're breathing are all ultimately built upon this violently boiling foundation. Every single second of every single day, you're floating on a microscopic ocean of unimaginable chaos. Yet, by some absolute miracle of cosmic architecture, this deep, chaotic storm perfectly averages out on larger scales to create the smooth, stable, beautifully ordered reality we experience. It is exactly like looking at a magnificent, highly detailed digital photograph. When you stand back, you see a beautiful, continuous image of a glowing galaxy or a quiet forest. But if you zoom in infinitely close to the screen, the smooth image shatters into thousands of tiny, harsh, glowing pixels. The quantum foam is the pixelated foundation of existence, the ultimate, indivisible building blocks of reality itself. This realization brings us face to face with the single greatest unresolved mystery in all of modern science, the magnificent quest for a theory of quantum gravity. For nearly a century, brilliant human minds have struggled to write a single, elegant mathematical equation that unites the heavy, smooth gravity of the macro world with the microscopic, chaotic jitter of the quantum fields. They are like two completely different, beautiful languages that the universe speaks flawlessly. Yet, they fundamentally refuse to be translated into one another. If you try to use the rules of quantum mechanics to understand the immense gravity of a supermassive black hole, the mathematics produce infinite, nonsensical answers. If you try to use the smooth geometry of relativity to understand the violently bubbling quantum foam, the equations completely break down. The universe is guarding its deepest, most ancient secret with absolute mathematical silence. Yet, the boundless human spirit of exploration refuses to quietly surrender to the dark. Driven by a deep, beautiful need to understand our place in the cosmos, theoretical physicists have proposed breathtaking, highly imaginative frameworks to gently bridge this impossible gap. One of the most famous and mathematically elegant attempts is known as string theory. In this profound vision of reality, if you were to peer deep inside the boiling quantum foam, past the tiny quarks and the fleeting virtual particles, you would not find solid little dots of matter. Instead, you would find unimaginably tiny, one-dimensional loops of pure energy, vibrating silently in the dark like the delicate strings of a cosmic cello. Just as different vibrations on a cello string produce different musical notes, different modes of vibration on these fundamental quantum strings would manifest as the different particles and forces we see in the universe. An electron is simply a string vibrating at one specific frequency. A photon of light is a string vibrating at another. In this beautifully poetic framework, the entire universe is not a collection of isolated objects, but a vast, continuous, magnificent symphony playing out across the quiet expanse of space-time. But the mathematics of string theory demand a profound sacrifice from our everyday comforting intuition. For the equations to work without producing mathematical contradictions, the universe cannot simply have the 3 dimensions of space we move through and the 1 dimension of time we experience. String theory requires the universe to possess 10 or even 11 distinct dimensions. Where are all these other dimensions? Why can we not see them or feel them as we walk through a quiet park or gaze up at the ancient night sky? Physicists mathematically propose that in the incredibly hot, dense fractions of a second following the Big Bang, these extra dimensions curled up or compactified into shapes so unimaginably tiny that they are forever hidden from our macro perception. They exist everywhere, at every single point in the vast universe, intricately folded up within the tiny, seething quantum foam. Every time you wave your hand through the empty air, you are unknowingly moving through a 10-dimensional landscape of mathematically perfect, invisible geometry. When we pause to deeply reflect on this invisible, vibrating, multi-dimensional architecture, our relationship with the universe fundamentally shifts. We are completely composed of these tiny, vibrating strings. The quiet thoughts echoing in your mind right now, the warm beating of your heart, and the brilliant light of the distant stars are all simply different notes in the exact same cosmic symphony. You are not just living in the universe. You are the universe beautifully, continuously singing to itself. The chaotic, boiling quantum foam is not something to be feared. It is the vital, energetic foundation that makes all of reality possible. It is the ancient, restless engine of existence, forever hidden beneath the smooth, comforting illusion of our everyday lives. But as we embrace this beautiful, multi-dimensional music, a new, deeply philosophical question gently arises from the silent depths. If the fundamental reality of the universe is not solid matter, but rather pure, vibrating information and mathematical relationships playing out in hidden dimensions, what does that mean for the nature of our own consciousness? Could the quiet, subjective experience of simply being alive, of wondering about the cosmos, be more than just a chemical accident in a biological brain? Could consciousness itself be a fundamental, woven aspect of the quantum field? As we continue our contemplative journey together, preparing to reach the final layers of this cosmic mystery, we must gently turn our gaze inward. We will explore the profound, beautiful intersection between the deep machinery of the quantum universe and the silent, observing mind. We will journey into the captivating mystery of quantum consciousness and the ultimate meaning of our place in the infinite dark. Have you ever closed your eyes in a perfectly quiet room, listened to the gentle rhythm of your breathing, and wondered where your conscious thoughts come from. We experience our minds as an unbroken, continuous stream of feelings, memories, and profound wonder. We feel a deep, undeniable sense of self, a quiet observer sitting just behind our eyes, watching the vast universe unfold. But when brilliant neuroscientists meticulously examine the human brain, they do not find a glowing, magical center of consciousness. They find a beautifully complex biological machine made of roughly 86 billion neurons, communicating through tiny electrical impulses and chemical signals. According to classical physics, you are simply a highly advanced biological computer, and your profound sense of self is just an elegant illusion created by the complex firing of ancient neural networks. But, as we have discovered throughout this contemplative journey together, classical physics is only a localized approximation of a far more mysterious underlying reality. The universe is not fundamentally made of solid billiard balls or mechanical gears. It is a sprawling, invisible ocean of quantum fields. And if absolutely everything in the cosmos is ultimately born from these mysterious, vibrating fields, then we are gently forced to ask the most profound, mind-bending question of all. Is human consciousness itself a fundamental property of the quantum world? To explore this breathtaking possibility, we must gently shift our perspective from the vast, swirling galaxies down to the absolute smallest structures inside your own biological cells. For decades, traditional science assumed that the warm, wet, chaotic environment of the human brain was simply too messy for delicate quantum effects to survive. Quantum superposition and entanglement, those magical states we explored in our silent laboratories, usually require freezing temperatures and perfect isolation to maintain their delicate coherence. But the natural world is a master of astonishing, unexpected engineering. In the 1990s, a brilliant mathematical physicist named Roger Penrose and an anesthesiologist named Stuart Hameroff proposed a mathematically rigorous, deeply poetic theory that completely revolutionized how we might understand the mind. They gently suggested that we should look inside the neurons, deep into the microscopic scaffolding that gives these brain cells their physical structure. They pointed to tiny hollow tubes known as microtubules. These microtubules are not just passive support beams. They are incredibly complex, crystal-like structures capable of isolating tiny, microscopic pockets of quantum activity from the chaotic, noisy environment of the brain. Inside these quiet, microscopic sanctuaries, the fundamental particles might actually be entering states of quantum superposition, existing in multiple states at the exact same time, just like the unobserved electron in the double-slit experiment. According to this beautiful, controversial theory, your brain is not just processing chemical signals. It is literally orchestrating billions of microscopic quantum collapses every single second. Each time these delicate quantum states collapse into a definite reality, they produce a tiny, discrete moment of conscious awareness. Your continuous flowing experience of life, your deep capacity for wonder, and your quiet ability to reflect on the mysteries of the cosmos might actually be the direct, tangible result of the quantum field gently collapsing within the ancient architecture of your own mind. If this profound idea holds true, it completely shatters the artificial barrier we have built between the observer and the observed universe. You are not a separate, isolated entity looking out at a cold, disconnected void. Your consciousness is fundamentally, intimately woven into the very fabric of space-time itself. We learned earlier that the act of observation mathematically forces the quantum field to choose a definite reality, transforming infinite probability into a single, solid universe. Now, we begin to beautifully realize that the observer and the universe are engaged in a continuous, eternal, and perfectly reciprocal embrace. The invisible, ancient fields of the cosmos patiently evolved over 13,800,000,000 years to create the heavy elements, the swirling galaxies, and the stable planets necessary for biological life. And in return, that biological life evolved the conscious capacity to look back out into the silent dark and give the universe its definitive, observed reality. You are the universe's way of gently waking up, opening its eyes, and beautifully experiencing its own magnificent existence. When you deeply absorb this staggeringly beautiful perspective, the way you experience every single moment of your daily life begins to profoundly transform. The comforting weight of the gravity holding you to the earth is not just a blind physical force. It is the ancient Higgs field and the invisible dark matter quietly holding your localized reality together. The gentle warmth of the sunlight on your skin is not just radiation. It is a delicate conversation between the electromagnetic field and the vibrating electrons within your body. The profound silence you feel when you gaze up at the vast glowing expanse of the night sky is not an empty void. It is a humming, infinite ocean of quantum potential, waiting patiently for your conscious mind to give it form. There is an absolute, undeniable poetry written into the rigorous mathematics of existence. The great astronomer Carl Sagan once beautifully stated that we are a way for the cosmos to know itself. This is no longer just a poetic metaphor. It is a rigorous, deeply profound scientific possibility that sits at the very frontier of modern physics. But as we reach this breathtaking pinnacle of understanding, as we recognize our deep, intimate connection to the bubbling quantum foam and the infinite branches of the multiverse, we also come to a gentle, humbling realization. The scientific journey is not about reaching a final, absolute destination where every single question is neatly answered and every mystery is permanently solved. If we were to somehow find the ultimate equation, the final theory of everything that perfectly unites gravity with the quantum world, it would not end our human need for exploration. It would simply open a brand new, even more magnificent door, revealing deeper layers of reality that we cannot yet even begin to imagine. The universe is infinitely vast, infinitely complex, and infinitely mysterious. Our human knowledge, as brilliant and beautiful as it is, will always be a tiny, glowing sphere of light surrounded by an endlessly expanding ocean of the unknown. And that is exactly how it should be. The mystery is not a source of frustration. It is the vital driving fuel of our boundless curiosity. It is the gentle invitation to keep wondering, to keep looking up into the dark. In this quiet, meditative journey, we have traveled together from the comforting illusion of solid matter down into the bubbling, chaotic depths of the quantum void. We have stripped away the empty space to find a seething, eternal ocean of energy. We have watched particles emerge from absolute nothingness, discovered the invisible Higgs field that gives the cosmos its heavy weight, and confronted the ghostly presence of dark matter holding the ancient galaxies together. We have stared into the relentless, expanding future driven by dark energy, and we have mathematically traced our origins back to the fiery seeds of the Big Bang. We have gently unraveled the invisible threads of the four fundamental forces, witnessed the instantaneous connection of quantum entanglement, and explored the mind-bending possibility that our universe is just one tiny branch on an infinite tree of realities. And finally, we have brought the vast, infinite cosmos directly into the quiet center of our own conscious minds. Yet, the most beautiful truth of all is that this journey is never truly finished. The universe will always hold something entirely unexpected, something so profoundly strange and beautiful that it will force us to reimagine everything we thought we knew. You do not need a billion-dollar particle accelerator or a massive space telescope to participate in this grand cosmic adventure. You only need a quiet moment, a willing imagination, and the gentle courage to let go of your everyday certainty. When you walk outside tonight, I invite you to find a quiet place away from the glaring lights of the city. Stand in the gentle darkness, look up at the ancient, glowing stars scattered across the vast silence, and remember what you truly are. You're not a small, insignificant creature living in a cold, uncaring void. You are a highly complex, beautifully localized ripple in the infinite ocean of the quantum field. Take a deep, slow breath and feel the reality of your existence. Every single atom in your body is a magnificent, impossible miracle of cosmic engineering. Allow yourself to feel a deep, peaceful humility in the face of this infinite mystery, and let that humility transform into a profound, gentle awe. The universe is an endless source of wonder, a quiet masterpiece that invites us to continuously explore, to continuously learn, and to connect with something unimaginably larger than ourselves. Thank you for walking alongside me on this contemplative journey through the hidden architecture of reality. If this gentle exploration has helped you see the cosmos in a new light, please consider sharing your thoughts with our growing community of fellow explorers in the comments below. Let us know how it feels to realize you are an intimate, conscious part of the infinite quantum field. And if you wish to continue uncovering the deepest mysteries of existence with me, please subscribe to the channel so we can embark on our next adventure together. Until that moment arrives, I invite you to keep your mind open, keep finding peace in the unknown, and never lose your gentle sense of cosmic wonder.